Hi. Now in this video, we are going to talk about Mempool. So let's start. So if we talk about our previous video where we saw that the current hashing rate is around 234 million trillion hashes, right? For the overall Bitcoin network. Okay. Since we are talking about Bitcoin, so it is around 234 million trillion hashes per second. And we also saw that if we talk about the number of nonce, we have only 4 billion nonce, that is 4 into 10 to the power 9 nonce. And if we will divide this by this total number of hashes per second, we can clearly see that 4 billion nonce will get exhausted in just 4 into 10 to the power 9 seconds. That is very, very, very less than 1 second, right? And we ended our previous video by this question: what should the miners do in the idle time? Because in less than 1 second, all their nonces will be getting exhausted. Now they do not have nonces, and if they do not have nonces, they cannot generate hashes. So they will never reach the target, right? So what they will do in this 1 second period of time? So should they wait for timestamp to change that after 1 second and then they will start again the nonce process? Or there is some solution to this problem? And there is a solution to this problem. And the solution is the transactions. As we know that our Bitcoin block consists of number of transactions, which we have seen in our previous video as well, right? So by changing the transactions, you will see by changing the transactions, we can change the hash, right? Because transaction is also one of the fields that we give to our SHA-256 algorithm. And when we will pass our transaction to our SHA-256 algorithm, then the output will also be generated. And if we will change the transaction, so because transaction is one of the input of our SHA-256 algorithm, in that case, output of our SHA-256 algorithm will change. Hence, we will have a different kind of a hash, right? So now the question arises, from where these transactions come from? These transactions actually come from an area that is called mempool, and we will talk about mempool in detail in our next video. But for now, just imagine that mempool is an area, okay, from which miners pick your transaction. So whenever you do a transaction, let's say you are sending some Bitcoin to your friend, this transaction will be transferred to this mempool, okay, which is an area where all the transaction will be there, and from this only miners will pick your transaction. So you can clearly see that I have, not actually I have, this mempool have a number of transactions, right? And this thing that you are seeing, ff3 abc d23 abc, so this is the transaction hashes and this is the fees, okay? Because as we know that miners also take a little bit amount of fees whenever they are processing your transaction, because they are, they are doing a lot of work there, right? They are solving this mathematical problem, and solving this mathematical problem requires a huge amount of energy, and for that they charge this a little bit amount of fees for your transaction, okay? So this is a very simple process. So here you can see that there are a lot of there are so many transactions. So there will be so many people who are doing some transaction. These transactions are actually being the part of this mempool, and now miners will pick their transaction from this mempool only. Now let me ask you a question. If you are a miner, okay, let's say if you are a miner, then which of these following transaction you will pick and put it inside your block? Okay, so let's say there is a transaction, there are a lot of transactions here, right, in this mempool, and now you are a miner and you have to create this block, and in order to create this block, definitely you need some of these transactions, and you need to pick some of these transactions into this block, and let's say you can pick around 4 transactions from this mempool. So my question to you is, which of the following transaction you will pick from these eight number of, I think there are eight number of transactions given in the mempool? What you will choose? Pause me for some time and answer me in the comment section of this video, okay, and see whether you are right or not. So I hope you have answered to the question in the comment section. Now let me tell you which of the following transaction the miner will pick. So you can clearly see that from among these transactions, this transaction, if you will see, has the most amount of transaction fee. And since you are a miner, you want to make some profit, then definitely you will pick this transaction as your first transaction, and you will put this transaction in your Bitcoin block, right? Second transaction that you will pick, since I said, right, you can pick 4 transactions. So definitely you will choose this transaction, because this, in this you are getting a transaction fee of 0.06, and in the same way you will choose this 0.05 and then 0.04, right? Because these transaction have the most amount of fees, and you will take these transaction, you will put this transaction to this Bitcoin block, right? Simple as it. Now you can clearly see that these transactions are also part of your Bitcoin blockchain, and when there will be a change in transaction, your hash will also change. Now let us go back to our question, that what happen if all the nonsense will get exhausted in less than 1 second. Let's start with that question, or let us start with the solution of that question. So let's say this is our clock, this is our beautiful clock, okay, and this is our current timestamp at 58, okay, which has not changed yet, okay. Let's say this is our nonce, okay, that we are using, and let's say in less than 1 second, in less than 1 second, you can just see the clock, just see this clock carefully, okay, just see this clock carefully, and you will see that in less than 1 second we have exhausted all our nonces, right? And still the timestamp is the same. Now what miner will do in this case, because nonces are exhausted, he cannot depend upon the timestamp, he can only do one thing in this case, and that thing is transactions. He can change the transactions given in this transaction block. And how he will do that? He will pick up a transaction which is having the least amount of value, okay, which is this 0.04, and he will replace this transaction with a transaction which is just below this 0.04, means below in the sense which is having a transaction fee of just less than this 0.04. And if you will see in this mempool, the 0.02 is a transaction which is having a transaction fee of just less than 0.04, right? And he will replace these two transactions. Now, as soon as he will replace these two transactions, right, you can clearly see that now miner can again use back all the nonsense, right? Because once he will change the transaction, the hash will change, right? Now he will have a different kind of a hash, and now he can again change these nonsense in order to generate the target hash, right? I hope this makes sense, because earlier, if you will go back to this situation, we were having some kind of a hash, right? And by changing the nonce, we were not able to reach to our. Now once we will change the transaction, like in this case we have replaced the 0.02 with 0.04. Now this hash will change, so now we can again reuse our nonce, right? Now let's say again he will start the same process, he will generate some nonce, and only less than 1 second he again, if you will see, he has again exhausted with all his nonce. Now what he will do? Again, he will check which transaction is having the least amount of value. In this case, you can clearly see it is 0.02, and he will replace this with this 0.01, right? He will not replace it with this 0.04, because again he will land up to the starting, right? So he will replace this 0.02 with this 0.01 transaction, and now again he is having an authority, or I will say not an authority, again he's having a power to reuse the nonce, right? And again you can clearly see that a timestamp is still not changed. So again he will start the nonce process, and boom, in less than 1 second he has again exhausted with all his nonce. Now what he will do? He will again do the same process again and again. He will replace this 0.01 with this 0.008, right? Now he will again start the same process. This is a repeated process, right? And again you can clearly see that he has exhausted with all his nonce, and let's say miner was not able to find the solution with the help of this nonce also. Now what will happen? Because now you can clearly see, we are taking an example here, or assumption here, that we have exhausted with all our transaction in our mempool. Okay, we can take this assumption. Definitely there can be thousands of transaction in our mempool, but I am taking this assumption that we have exhausted with all our transaction in our mempool. Now what miner will do in this particular case? And the answer is, if you will clearly see here, the timestamp will change after this 1 second has passed, right? Till now, the cases that we were dealing with were less than 1 second, right? So we started with this less than 1 second, less than 1 second, less than 1 second, and now we have reached our 1 second. Now, once we will reach our 1 second, boom, our timestamp will change. And since our timestamp has changed in this case, now you can clearly see that the miner can again restart the process of nonce. He will again take the transaction which is having the, he will again take the 0.04 which he has replaced earlier so that he can find the solution. He will again take this 0.04 because this transaction is having the most amount of transaction fee as compared to the remaining transaction, and he will again start the process of this generation of nonce. And if he will be lucky, he will get the answer in this case. Otherwise, again, the same process that we have discussed, right? This process will get repeated again and again till the time he will find his solution. So I hope this makes sense. Let me just give you a quick summary to you if you are still not able to catch up with. Just let me give you a quick summary to you once again, okay? So we started with this position, okay? And we exhausted with all our nonsense in less than 1 second. So we replace our 0.04 transaction with 0.02. And now again, we will start with our nonsense. Again, we exhausted with all our nonsense. Still, we haven't reached to our solution. So what we will do again, we will change the transaction, means we will replace the transaction. So 0.02 was replaced with the 0.01. Now again, the mining process will start, and boom, again, you can clearly see that we are assuming that, okay, the miner was not able to find the solution and he has exhausted with all his nonce. Now what he will do again, he will again replace, replace this transaction, the 0.01 transaction with 0.08, and again he will start the same process. Okay, 0.08, and again he will start the same process. And once he will reach to this 1 second, and let's say he was not still not able to find a solution, he will do nothing. Just he will wait for the timestamp to change, and once the timestamp will change, again he will be in power to use the nonsense again, and he will also take back his piece, right? This transaction fee of 0.04. Why he's taking back his 0.04 transaction? First, this is the transaction fee, this transaction is having the most amount of transaction fee as compared to the remaining transaction. Second reason is because the timestamp is changed. So with the timestamp is changed, he will be having a different kind of timestamp, right? Not timestamp, actually different kind of a hash for this block, right? And due to which he can again use the nonces, and again the same process will start until or unless he will find the solution to his problem. So I hope you understood this by now. If you have still any doubts, please let me know your doubts in the comment section below. I will be happy to answer your doubts. Okay. And yes, let me tell you one more important point in this video, that never try to have a transaction fees which is too less. Okay. So always see that what is the current market transaction fee rate. If you will have your transaction fee too less, in that case, what will happen? Miner will never pick your transaction. In this case, because miner, let's say our miner was not having any option, right? That's why he picked this 0.008. But still, you can clearly see that 0.008 is way less than these transactions. So chances that this transaction will never be picked by the miner. Okay, so just be careful if you are doing any type of transaction, cryptocurrency transaction on a Bitcoin or any other type of a blockchain. Just remember that your transaction fee should not be so less that the miner will never pick your transaction from the mempool. Okay, and in the next video, definitely we will talk about this mempool in much great detail. So I hope you like this video. If you have liked this video, please click on that like button. If you are new to this channel, please subscribe to this channel, because I am regularly going to upload new blockchain courses on this channel. If you want to connect with me directly, you can join me on Instagram. You can talk to me directly there. If you want to join our blockchain developer Discord community, link is given in the description of this video. Please join that link. And if you have still any doubts regarding this video, I know because this video was a little bit complicated, please let me know your doubts in the comment section below. If I have to, I will make a new video for you if you are not able to understand this concept. Okay, meet you soon in the next video. Till then, bye bye.